Hello. Having understood the basics of classification, now let's look at how classification can be implemented through pipelines. Now for that, I'll be using Orange data mining tool. So in this one, we'll be looking at three aspects in data mining. Number one, how to see the profiles of data. Number two, how to do the classification, identify the best algorithm. Number three, how we can do a prediction. Okay. So this is the Orange data mining tool. So if you are new to this, after installing Orange, you need to go to add-on widgets and install the relevant add-ons. However, I have installed this before. It will take little time. So therefore, when you are installing it, make two things. One thing is you install this before because you need to do a couple of restart. Number two, when you are getting an error message, check whether the error message is about the disk space. Because if you are installing all these add-ons, it will take long time to install. So in my case, I have not installed all things. I say others will give me an error, so therefore I install only the relevant add-ons only. Right. So then let's look at the data sets. So here, these are the available data sets in Orange data mining. So you can see here the categorical data, which is what we are going to analyze. If you remember, classification is for classify supervised learning, which you need to have labeled data. So so you can search this one here. So let's say right. So you can see the cancer the data, right? Cancer data set is available. Iris data set is also available, and then weather data, glass data is also available. Then likewise, there are common data sets that are available. So let me go to the glass. Let's go to the iris database. If you remember, we discussed the iris database in using Inveca as well. So this is our data the iris datasets. So let me rename this so that yeah, let's see, since it's only one, we can go with this data, but if you want, you can rename this. I can say iris data set. Right. So before we moving into anything, let's see some properties of this data. So one thing is you can view this data using data table. So you can see the data, sepal length, sepal width, petal length, petal width. Those are the common data, and also you can visualize this, right? Depending on you can get an idea. For example, this one says it's a high value, 3.4 high value compared to the other values. Also, you can get the data info, which is the summarized version of your data. So it says you have 150 records and 5 columns. 4 of them are numeric. So likewise, it describes about your data. And also you can go and do a feature statistics. which will give you an update about what's the mean for each value, mode, median, minimum, maximum, any missing values, so you can identify that. Now, when you're working with the industry data or the real world data, you will have the missing values. In classification, you can have missing values and continue. I'm not saying you can have large number of missing values, but you can have a missing values for some percentage, and then from that you can continue your uh, classification model. Right, so if you're interested, you can draw graphs as well. Sorry. You can do some graph as well, or there you can go to some statistics, right? You can go to some statistics and view this, right? So color wise, so how the Irish these flowers are distributed, right? So there are a lot of parameters which I'm not going to explain here. And if you want to draw any graphs, let's say bar chart, bar plot, right? So you can draw the for different iris flowers, Setosa, versicolor, and virginica. What's the distribution of the sepal length? Now you can see here, iris virginica sepal length is high, comparatively high. Likewise, you can view the sepal width, sepal petal length. You can see a clear distinguish between these data. So that's about also you can draw any box plot. You can draw a box plot for so this is for different colors, sepal length, how the sepal length is distributed. Sepal width, this is the distribution. Petal length, this is the distribution, and petal width, this is the distribution. Now, normally, as you know, box plot is said to be the 5 number parameter, right? It's describe about a data with 5 numbers. This one, um, median, and these 5 numbers will describe about that particular data set. So this is a very common analysis that you do. Now you can see here from this tool, you can get that analysis done. So with that, we are completing the first section, that is getting a information about the data set. So after doing that, next one is the identifying the what is the best classification model. In the interest of I can open a uh, new file, but I'm not going to do that. I'm going to use this one for all the other tasks as well. So if you remember, in Weka, we use multiple algorithms that were available there to find the best algorithm. If you remember, depending on the your requirement, you may go through the precision, recall, accuracy, likewise, and F1 score, likewise. So here also we have, if you go to modeling part, we have lot of algorithms to select with, right? So this is what we are going to do. We will have a test score. Remember, we did the splitting our data. So here we can split our data from the cross prediction. From the cross prediction, we can do the splitting. So unlike Weka, where you can consider only one at a one view only, you can do that. If you remember, you have to do one and then do another one. If you have to compare, there is no one single view to compare. But here you have that advantage. Now here you can connect with multiple algorithms like this and uh, compare this. So I have added KNN tree, random forest, gradient boosting, SVM, linear regression. Linear regression will not work here. Logistic regression, naive Bayes, what is, okay, neural network. So likewise, you can connect and identify what is, now you have connected all this, and then using TextScope, you can get the comparison in a one view. So you can see this. I have done the cross validation uh, with 5 folds, 5 folds. Now, one important parameter here is Startify. Now, in Startify, what you do is when you are creating folds, you make sure every fold contain similar distribution. Now, in this case, for example, we have 50 Virtuosa, 50 Virginica, and 50 Versicolor instances. So when you are distributing your folds, each, now that means balanced data set you have. So in every folder, also you will have the balanced data set. In case of unbalanced data, imbalanced data, when you are creating folders, that folder will have uh, same distribution, which is very advantage when you are working with imbalanced data, right? So if you look at here, you can see, right? So you can see the best model. The values are not much, uh, not drastically changing here. So if you look at this, if I go by the F1 score, which is the harmonic mean of precision and recall. So here, except for the naive Bayes, all the other models are around 96%. So by looking at this, yes, KNN is the best model, but by marginal number, right? So that's how we can choose the KNN model. So yeah, and then we can do the confusion metrics as well. So if you do the confusion metrics for each model, we can go and check the confusion metrics to identify what is the better. If you are looking at any specific algorithm, right, you can go and check the best if you are looking for any specific class, you can go and check the specific class from this rather than looking at the all the other classes. Sometimes, for example, if you are in even this case also, you have 3 classes for flower. Sometimes you might be only interested about only one class, only one flower. So in that case, you can choose that particular one only, and uh, then you can look at what's the best for that particular class and select that. It's not only about the precision and recall. In that case, you'll be looking at a very specific class, and then you are looking at that particular class have the best values, and then you can select that. So this is the our second task. This is our second task that we did. So here, as I said, we have a uh, one more task here, that is the prediction. Now, if you remember in Veka, there was no option to predict. Now, what is the idea of building a model? Now, once you build the model, so model is to predict the unknown classes. Now, here we have uh, iris flowers, 4 parameters, and then we have the label data. Now, idea is we have a model. From the known values we have built the model. When we get a data, let's say unknown flower, we have received unknown flower with the petal length, petal width, sepal length, and the sepal width. What is the flower type for this? That is the idea of the classification. It's not only about getting the best model. Yes, we get the best model, and let's do the prediction part as well. Right. So let's do the prediction part. Okay. So let's do the prediction part. I can use the same controls, but for the cleanness, I'm not going to use the same controls. But let me copy paste this. So I have the iris flower uh, control, and let's take that, right? And then, so I said that my best model, let me verify what my best model. Yeah, okay, my best model is KNN. So let me select the KNN algorithm and then do the prediction, right? But so we need to input unknown label data, right? So for that I'm going to import from a file. I already have a file, so let me input that file. Right, so this is the file that I have, and let me do a data view for this just to show you. Right, so you can see I have a flower with sepal length is this, sepal width is this, petal length is this, width is this, but I don't know what the type is. So what we are going to do is, by using the KNN model, we are going to do the prediction. So we will be connecting to this, and then we have the prediction. So it says, okay, this is a iris versicolor. So I want to see the probabilities as well. So you can see it's a 100% accurate probability, that is, this is belongs to iris versicolor. So here you can see, you not only, so here we did three things. We analyze our data set, which is very important, descriptive analytics of our data set, which is you can do it much easier. And then we select the best model for this, and finally we did the prediction, which is what very important aspect of classification model. Also remember, there are, if you go these, you can do some parametric changes for this the classifications for this the classification algorithms. uh, Algorithms like this, the how much you split. So each and every algorithm has its own parameters, which we are not going to discuss in detail, but you can change those parameters to get a best value. But here we don't have to do that, because we are already getting a better algorithms. Now if you want to, so during the class, we will go through the, like what we did last week. We will select few uh, data sets uh, from the arranged available sample data set, and we distribute the among the class, and then we will discuss that. Later we will do our project, the given project as well. Hope you learn. And now again, the orange data mining is a very simple tool, and it's very simple, unlike Veka, which is very, you can use this tool, and better visualization, better support is available. Also very importantly, you can save this file and use it for a different day, which is not an option in the Veka, the what we use, but there is another option which we will discuss little later date. Hope you got through this, right? Let's look at your exercises during the class. Thank you very much.